Hello. Well, welcome everybody. Welcome everybody. Welcome everybody. We are in two places. We are in Blackboard Collaborate Ultra, where of course you can ask questions. It'll be reserved to the class. Also, I will do the polling there. And we are on Twitch as well. You can ask questions in Twitch chat. It's over there. I will be, but remember, anything that you share in Twitch chat is public. Well, if you want things to be private within the class, go ahead and speak on Blackboard Collaborate Ultra. So my name is Scott Grizzard. This is from the University of South Florida. This is the quiz review for, where are we, 4A now? This is the 14th of September. I think I said everything. So it's test week. Test week. How's everybody doing about the test? Okay, so some things that are going on about the test. Let me go ahead and talk about that first. Let's get rid of Blackboard Collaborate Ultra's window here that's annoying me. Let's get rid of this. That's annoying me. And let's talk about the test for a moment. So it's test week. And there it is. So, a couple things that are changed about test week. The first thing, office hours on Friday are virtual only. There are no live office hours, but there are extended virtual hours. And all of this will become an announcement as soon as I finish. There will be a test review at 7 p.m. Wednesday night on Discord. I'm going to try to do one Thursday during the day, but I don't know if that's going to happen yet. So office hours Friday are extended and they're virtual only. Now, earlier on that Friday at the 12:30 time, Discrete Math has their test. So I have to proctor that. That's why the office hours get moved. Okay. So online now, if you go into files, you will actually see the test review. So let's see. Screen 2. Yes. So if you go here into files, you go into files, test reviews here. Here you will actually see, go to test 1 and you will see the exam 1 review. On the exam review sheet, you will see all the things about what time it is, all these things. You have 75 minutes to take the test and then 30 minutes to deal with technology stuff. Is the official thing. So if you're having trouble with Proctorio and it eats your time, we built in time for that. And if you're having trouble scanning with your phone, we built in time for that. Now, remember that what you're going to do is log on to Discord using your phone. There will be a room. I'll go through this again on Wednesday, exactly how this works. But what you'll do is you'll log in on Discord. You'll log into the room on your phone. That way, if you have any issues, there'll be a special chat room called Hand Raised. We'll have some proctors in there, and of course, I'll be there. And if you have any issues on Saturday, we'll try to get those resolved. Like if the internet cuts out, the power cuts out, all these other things, that's why you need to be on your phone. Okay? So that we can deal with issues if you have them. You will see here that extra study session. Okay, I didn't fill that stuff out. I'm giving it to you right now. All of these things here. And then these are the things you have to be able to say, to state. There are some extra book problems. So that's the section. These are the examples from the textbook we advise you to read. And these are the problems. Every once in a while, we throw one of these on the test just to, keep you on your toes and make sure that it's useful, so, you might want to watch those. And then the quiz questions. The quiz questions, these are the ones that I highly recommend you look at before the test. So I've seen the test, at least its current draft, and the quiz questions are pretty good facsimile about what's on the test. These are the calculators that are allowed. The MS is also allowed. I haven't changed this form yet, but it is there. So all of that stuff is there in the file section. Now, that's the quiz review. Now, there's something else here. There are two test reviews on WebAssign. Both are extra credit points. They are there's something called like Dr. H's WebAssign. That's Dr. Hernandez. I swiped her WebAssign review. And then there's also a true false review for kind of concepts. Both are worth extra WebAssign points. And then there is something called the bootleg. Now, normally you would already have it, but this is what the bootleg looks like. And if you've heard about me, you've heard about the bootleg. So the way the bootleg works is it's the test review. So my bootleg got stolen. Apparently, some of the instructors last semester were complaining that I was giving an unfair advantage by giving an extra bootleg review. To which I responded, well, yeah, my students got an unfair advantage because they had a better instructor. But, you know, that didn't go over well. So now the bootleg is for everyone. So the head honcho boss lady here took my old bootleg review. She changed a bunch of the problems and cooked this up. And called it test review. And of course, I've recalled it bootleg and I've added one more problem to it back. Okay. So this is 16 questions. It's worth 40 bonus points on your quizzes. That's 2 quiz grades. Okay. This thing is worth 2 quiz grades, but it's all extra credit. Okay. This is longer and harder than the actual test, but it's got the same formatting, the same type of instructions. The questions, though, are another level harder, and it's a lot more proofs. There are nowhere near this number of proofs on the test. So again, longer and harder than the test. Basically, if you can bootleg, you can do the test. Now, just like a regular quiz, for me, you get in advance, but then you have to take a closed book on Proctorio before 1 p.m. on Friday. It will close then. The reason why it closes is because at that time, the buffering just overflowed. Okay. At that time, I'm going to release the key. Okay. So some of the questions are ones that you'll see, like state definition of continuity, formal definition of the derivative, 2 cops, etc., etc. I am waiting on this right now. I haven't posted it yet because I have to wait because there's a bug in Windows LaTeX file. So I'm waiting for the thing to install right now in Linux in the subsystem so that I can recompile this and get rid of that bug, which is annoying me. So you'll get this as soon as this thing finishes installing. And as soon as it finishes installing, I'll compile it and put it up there. Okay, so that is the bootleg. Are there any questions? Let's see. Let's see. Questions. Bootleg is due Friday. Are we going to have a quiz on Wednesday? Yes. Is uploading a picture as a PDF the same as scanning? Yes, if you get it working correctly. So you want to use one of those PDF app things. Especially you want to do that for the test and because it's lots of pages, and you're going to want to make sure you're not trying to get images uploaded. Okay. Yes, we will have a review in Discord. That will be on Wednesday, and I will post all the things. Hopefully I'll have time to do one on Thursday. I don't know yet. Because remember, Discrete also has their exam on Friday. So whereas yours is on Saturday. So I'm trying to plan on one being during the day. Okay, the cutoff for the test. The review on Wednesday is at 7 p.m. Review Thursday pending. It's right there. Yes, you can use a real scanner to scan the test. Proctorio will flag you, but that's okay. We'll clear the flag. So the way that Proctorio works is it flags suspicious behavior. The TA is going to go in and go, nope, you were scanning. Nope, you were scanning. Nope, you were scanning. Nope, you were scanning, and be done with it. It flags you anyway if you use this. So yes, 7 p.m. Wednesday is a test review. Yes, there is peer leading this week on Friday. I think that's all the big questions. Okay. So if you have more questions, feel free to ask, but I am going to move on, and so that we could talk about the quiz. Okay. So this quiz, it was mostly definitions. This very long thing right here, the limit as x goes to a, what's the definition of continuity for a function at a? Remember, this can also read a continuous function at x equals a. I hate the x equals thing. It's at the number, not, or at the number in the x space. It's not x equals, but they like x equals, so fine. What is the definition for continuity? It is that the limit as x goes to a of f of x equals f of a. So how do we feel about that one? Let me get this up. I really wish that there was an easier way to do this and I could have the things done in advance. Question 1. And then it does this. It like skips. Question 1. That's annoying. All right, so 1 to 5, how do we feel about that little definition there? You could have also said the working definition, which is, f of a is defined and the limit from the as x goes to a from the left equals the limit as x goes to a from the right equals f of a. You can't say, like, I didn't lift my pencil. That's the formal definition of the limit. You could also use the delta epsilon definition from the notes, but why? Why would you do that? Okay. All right. Let's see. Polling, multiple choice. Okay. I want to stop this now. All right. Let's go on here. So to do this definition, here's how I did it. Let's do this down here so I can do a nice little thing. Okay. So, oops. Okay, well now the pen is gone. The cards are everywhere. Here we go. All right, so here's how I did this. State the intermediate value theorem. So the first thing I did was I remember my little thing. So this is what I remember. If I drop a ball from 6 feet to 4 feet, there's a time when the ball is 5 feet. Okay? That's kind of the metaphor I remember. Here's the picture I have in my head. Not there. And then I have this, there is a time when the ball is 5 feet. There's my 5 feet. And there's my time. Okay. So that's how I remember it. I remember that there are these two conditions and one conclusion. So if f is continuous on AB, and if, I don't need the if there, if V is strictly between f of a and f of b, then there exists u in a b so that f of u equals v. Okay. And then I remember that there's some kind of preamble that I can write. The preamble, writing the preamble is optional. You get refund points. So the preamble here would be f defined on a b, which puts that in the x space. And then v is in the y space. And that's it. So 1 to 5, how do we feel about that definition and how to reconstruct it? Let's see. This is question 2. Start. 1 to 5, how do we feel about that one? By the way, I actually used the intermediate value theorem today. If you want to know. Oops, didn't want to hit that. If I go here to my algebra notes, my graduate algebra, right? Well, I don't know how real life it is, but here's the question I had. Let R be the ring of functions from -1 to 1 to R. Defined there. F this piecewise function, G this piecewise function. So that that F divides G and G divides F, but there's no unit, so that G equals UF. And look at this. So I had to prove continuity. And remember, I'm in graduate school. This is for my PhD. And then the second part of this problem, I needed the IVT, right? Because I wanted to say that there was some point where it had to be 0. And because there was some point where it had to be 0, you couldn't be a unit. So there it is. I used it today on a very hard problem in graduate algebra. So, it sticks around. I thought I was actually kind of excited that I got to use the intermediate value theorem. I was like, yes, I'm teaching this right now. They come back. I actually answered a analysis qualifying question, which is, the qualifier exam for your PhD, by showing that a particular function was both even and odd and therefore had to be 0. And it saved me a lot of time because it was supposed to be a really hard question. So sometimes the simple tricks stick with you. Like any of you are ever going to need that, right? Well, I don't know. 1 or 2 of you might go on. All right. Any questions about that? Okay. I'm not sure it's a real life example, but it's an example of using it today. All right. This one, the way I remember it is well, at this point I just remember it, but the way I remember it's the slope, but there are a lot of definitions. I would have these 2 memorized because there's times you want to use them, you want to use one definition, and there's time you want to use a different definition. So for instance, on the bootleg, if you go down to the bottom, of course you can't yet because it hasn't finished installing. But if you go down to the bootleg here, in this last question, you see how I say you may want to use the t to x definition of the derivative? That's because that's a better one for these 2 problems, whereas the h definition is better for most of them. But there are problems where the t to x definition is better, so you may want to have both on you at the same time. But these are the 2 definitions. This fix x thing, totally optional. It's just to remind me that the x gets its context there. That should be an x, not a thing that looks more like a chi. And then this right here. Do we have any questions? So how do we feel about the definition of the derivative there, 1 to 5? So this is question 3. Just the limit definition of the derivative. As I said, you don't need that fixed x. All you need is that equation. But you need both sides of that equation, right? Because this x doesn't make sense. This x here doesn't make sense unless you have that x there. Okay. Okay, so the definition of the derivative. And again, this is kind of the part of the thing. But you have to remember it's the limit. The way to remember it is the limit as the change of x, of the change in y over the change in x, as change in x goes to 0. That's one way to remember it. Or this little drawing here where x plus h is heading to x and all of these things. But the point is that x is fixed. And yes, you can use a instead of x if that makes you more comfortable. But you have to use, if you use a here, you need to use a everywhere. So it's got to be f prime of a equals the limit as h goes to 0 of f of a plus h minus f of a all over h. And that's fine, right? But this thing and this thing and this thing must match. And then this thing and this thing there must match. Right? I could use something else like W or Q if I wanted to. Doesn't matter. And then these things, this F must match with that F and that F, obviously. Okay? So the particular thing that you use is up to you. You mean, I could even write this if I wanted to, if I wanted to really hate people, I would go, well, A of F, A prime of F equals the limit as x goes to 0 of A of F plus x minus A of F all over x, right? Don't do that. It's horrible, but I could. Which symbols you use don't really matter. Yeah, let's not do this. But I could if I wanted to. Just that a would become the function. X is the thing under the limit. And f is the point in x space. It's just... Let's not do that, but I could. Okay. Now, I want to prove that x to the fourth plus x minus 3 has a root in between 1 and 2. So what I want to show, and notice how I wrote it here, there exists a u in 1, 2, so that f of u equals 0. That's what I want to show. And my strategy is just going to be using the intermediate value theorem. Okay? So if I want to use the intermediate value theorem, I need to show that I meet the two conditions of the intermediate value theorem. So that's what I do. F is a polynomial, thus f is continuous everywhere, in particular on 1, 2. That's nice. Meets condition 2. Well, f of a equals f of 1, right? I plug in 1, and I get 1 to the fourth plus 1 minus 3, negative 1. I plug in 2 for b, and I get 15. Right? Thus, v equals 0 is strictly between f of 1 and f of 2. Therefore, by the intermediate value theorem, right, I checked to make sure I met both conditions. I did. Therefore, it must be the case that there exists a u in 1, 2 so that f of u equals 0. And then I kind of give it a little tagline. Thus, f has a real root in 1, 2, QED. Okay. So how do we feel about that one, 1 to 5? Oops, not question 7, question 4. Yeah, so we'll have a couple different... F prime just means that it's the name of the function that we give to the derivative. And Okay, the derivative, I did that. Let's not do that. So the derivative is the change. Yes, it's the limit of the change. It's the best estimate of the change. It's the change at the margin. Okay, and there are a bunch of different derivative formulas. All of them are equivalent. Okay. Any questions, by the way, on this one? Okay. By the way, about those different formulas, there are a bunch of them. Let's talk about those different formulas real fast. The two definitions are equivalent. So let's look at this one in the H definition, right? If I have f prime of x equals the limit as x goes to t of f of t minus f of x over t minus x. And the important thing here is that if t goes first on the top, then t goes first on the bottom, or vice versa, right? I could put x first on the top as long as I put x first on the bottom. If I do that, I'm just multiplying the whole thing, the top and the bottom, by -1 together. So it's, just multiplying by 1 the whole thing. So if I let h equal t minus x, then t becomes h plus x. So I just do the replacement. Instead of f of x stays the same on this side. Now I take the limit as x goes to 0, as t goes to x, h goes to 0, right? Because the limit as t goes to x of h is this thing right here. So I replace this x to t with this h to 0. And then I replace that t there with h plus x. That just stays the same. And this t minus x here just becomes h. So the two definitions are equivalent. It's just algebra. How do we feel about these definitions, 1 to 5? I'm going to ask one more time. And remember, that's kind of the whole point of the first module. Yeah, so you normally don't have to find. So there's notes on Canvas which mention the left derivative and the right derivative. Okay, and I'm going to talk about that tonight at 7. But that's important when you want to solve problems like this. So the way that you do these, it's a very good question. The way that you do these, right? The derivative is just a limit. So it's possible that the limit from the left does not equal the limit from the right. Okay, for this difference function. And if that's the case, or if the derivative comes out to be infinity, then I don't have a derivative. So there is a derivative from the left and there is a derivative from the right. The book doesn't like to talk about it. I mention it, but just like there are limits from the left and limits from the right, I have this idea of a derivative from the left and the derivative from the right, which is just the limit from the left and the limit from the right of that difference function, of that difference equation. So I can have situations where the derivative, where the two derivatives are defined, but they aren't equal to each other, because the slopes from the left are headed in a different direction than the slopes from the right, and I get a kink. And the classic example of that is the absolute value function. You're just asking that, so I'll say it. So if I've got something that looks like this, right? If I've got f of x equals abs of x, right? Which equaled this, which equals x if x is greater than or equal to 0, negative x if x is less than 0, and it looks like this. Right? So the slope from the left, oops, you can't see that. So if I have something like this, right? The slope from the left at x equals 0, the slope from the left is -1, but the slope from the right is 1. So here I have a kink. F prime of 0 does not exist because this function is kinky. Okay, it's got a kink in it, like a hose. Kink. It's got kink. Are there any questions about that? Does that answer your question? Okay. Okay, so yes, so the derivative from the left and the derivative of the right happens sometimes where they're not equal. Which, remember, it's just the limit from the left and the limit from the right, right? So that's the big thing to remember. All right, any other questions? Good question. Okay. Well, if that's the case, yes, so functions that are polynomial are always continuous. Other examples of stuff that's always continuous is sine, cosine, combinations of polynomials and sine and cosine. Rational functions are continuous where they are defined. So as long as a rational function is defined on an interval, it's continuous on that interval. Let's see, what else? Exponentials like 2 to the x, e to the x, and logs are both exponentials are defined everywhere. Logs are defined are continuous everywhere. Logs are continuous where defined. So if you go negative, there's no log. But if you are like if I'm on 0 infinity, log is continuous everywhere. The exponential function is continuous everywhere. Most of the stuff that we'll be playing with that aren't piecewise functions are continuous everywhere, and some of the piecewise functions are continuous everywhere. But you have to check those. Any other questions? Good question. Okay. All right. So what I'm going to do is I'm going to stop streaming on Twitch, and we are going to break out in groups for the problem set. Let's see. How do I do this? That button.